everyone, welcome back to Sensible SENCO. This is a 10-minute SEN Snippet and this one is about dyscalculia. So we're going to go through a definition of dyscalculia, what difficulties that might be faced by somebody with dyscalculia, and a couple of activities to kind of explain where those difficulties come from. So first one then, definition of dyscalculia. Dyscalculia is not having a sense of number. In other words, when I say 2, not knowing the 2-ness of 2 or the 3-ness of 3. And it really, literally, from Greek, means difficulty with number. What difficulties do students have then? Okay, get ready for your list. Every child is going to be different, but commonly they're going to struggle to understand the maths that uses everyday language. Common meanings, we're going to struggle with the word big. What do we actually mean by big? Big number actually doesn't necessarily mean it's a big number. Confusion with mathematical symbols, a little bit like dyslexia, switching things around, and their meanings. Needing to calculate number bonds from scratch every time, so not knowing that 5 and 5 make 10 and 3 and 7 make 10, but having to go back and recalculate those every single time. Confusing numbers, for example 3 and 8 or 6 and 9. Students might struggle to subitize. Subitize means being able to see an arrangement of numbers, what we call it an array. So this is an array of numbers and it's 3 here, and I didn't even need to count that. I can just hold it and I can see it and I know it's 3. Doesn't need to be in a particular pattern, they could be anywhere on that page, but I know straight away. Children with dyscalculia generally cannot subitize numbers less than 5, and that's not many. Students may regularly miscount. They have a poor sense of size, time, space, distance and direction. They can't visualise a number, so when we say 1,000 or 1,000,000 or 1,000,000,000, they have no concept of the greatness in size of each of those. They don't see patterns and sequences with numbers. They might give you an odd answer, so when you say how many sweets are left, they go yes. They have anxiety about maths. Every child will be different, some will have more difficulties than others. A couple of activities then. First one, take a number line, imagine one between my fingers, and at one end it's a 0 and at the other end it's a 10, but don't mark them. So I'm just saying to you, it's going from 0 to 10. Where will 7 sit on my imaginary number line? Students with dyscalculia will find it very difficult to answer that question. Or give them the number line again from 0 to 100 and ask them, where should I put the arrow to mark 50? Second activity, having a look at arrays. So I have an arrangement of arrays in my box here. And if I hold this up, you can see there is 1 on here. Doesn't matter where I stick it on that little grid, there is 1. If I hold this one up, I want you to tell me how many is on it. Did you count? I bet you didn't, but you knew it was 4 straight away, even though it's not in the regular arrangement for 4. We would normally arrange 4 like so. Okay, and let me pick up one more. You ready? 3. But I bet you're not counting them. Children with dyscalculia will generally have to count every single time to double check how many are actually there. Okay, our next activity then, taking a set of number cards from 0 to 9. If you're wondering where these resources are from, they're from Spot On With Number, and that's a video that I've just sat and produced to do with opening their box and having a look at the resources. And they were perfect for this. So what we're going to do with students is we're going to show them a number. What's the number? And chances are children with dyscalculia may actually be able to do this. So if I show you another number, what's the number? They might be okay with it. Very often they do find it difficult, but you know, generally it might be okay. However, if I said to them, right, here you go, here's the numbers from 0 to 9, make me the biggest number you can. That's when they might struggle. Some children will have a flick through and they'll find the number 9 and tell you that's the biggest number. Some children may need that defining a little bit more to say, okay, using 3 cards, make me the biggest number that you can. Let's hope that they choose 9, 8, 7. because that would be the biggest number possible out of these cards, or make them the smallest number that you can. Children with dyscalculia find that an incredibly difficult task, even if they are age-related expectation in being able to do a lot of other things. Okay, the next one is called a number stroop test. It's where you have words presented, and those words are colours, so red, green, blue, for example, and those colours are presented in the wrong colour. So I have one ready-made on the top of my sheet here, and we'll flash it onto the screen because I'm sure it would work better. We can see some words written with the wrong colour. And the idea is that you are supposed to read out the word. Sweetheart, could you just read out that top line for me, please?
Red, green, blue, yellow, blue.
He always likes to prove me wrong, doesn't he? Would you like to read the colours?
Blue, yellow, blue. Oh, no, I can't. I can't do it the other way.
Okay, interesting. With a number stroop test, what we're going to do is we're going to look at this row here and we're going to say which is the bigger number. Now straight away we've got a language difficulty, so EAL pupils are probably going to give you the wrong answer unless you've defined what you mean by the bigger or larger number in the first place. So looking at that first one, sweetheart, which one's the bigger number? The 8 is the bigger number. Now it wouldn't actually matter because in this one 8 would be the bigger number, but also the bigger value number anyway. In the second one, what's the answer?
6.
Which is also correct. And in the third one, what would be the answer?
8.
It's the 8, even though 3 is the physically bigger number. Children with dyscalculia cannot do this quickly. So it's not to do with that they can't do it at all, but they can't do it naturally and quickly. So what are we going to do about it? Okay, giving children strategies to use that involve what is around them. So if you are not delivering a maths lesson, let's take away the anxiety that's involved. So ceiling tiles are usually a regular size. If a child knows the size of the ceiling tile, they might be able to do some estimation if you're asking them to do something like that in a geography or science lesson. Let them use a ruler. Rulers have numbers marked on them and they're in the right order. It works as a really helpful number line, especially if you're not allowed a number line in an exam or something. So we can count on from 10 to 15 and work out what the difference is between them by physically doing it rather than anything else. Give them manipulatives. Let them use the pencils that are in their pencil case and count with those and move those around. Or give them a box of counters or deans or whatever it is you actually have to hand. Let them use their fingers and toes if necessary. Let them use a calculator and let them use their mobile phone. Yeah, I know you're going to shout at me for that one, but mobile phones are absolutely great. It's what they're going to take through life with them. So let's let them use the technology that they have and give them a skill they can take away and use for the rest of their lives. Give them graph paper for doing calculations. One of the biggest problems with dyscalculia is the fact that in English we read from left to right. In maths we work from right to left and very often from top to bottom at the same time. It's not a natural way of working in maths. Giving children graph paper to work with allows them to line things up. Remember their place value, so that 10 and 1,000 is a little bit skew with. So giving them that chance to line things up and make sure the right hand side has got the same on it and decimal points are all lined up will really, really help them. Break the maths down, chunk it. If you've really got to learn something, I'm thinking physics here. I remember trying to learn my physics formulae. If they've got to learn it, then break it down for them. Make it make sense. Put it in an everyday context and let them learn it that way. Point out patterns, point out sequences and use them. So if we know that this is 5, this is always 5 because there's nowhere else to put any more dots. It's filled, it's 5. Filled is 5. Use it, we see it, we use it, we can work it out. 4 corners of a room, we know that one, so there must be 4. Unless you've got an odd-shaped room. Use music and rhyme if possible. Probably more likely in a primary school, but if in a secondary school, let's have some fun. Let's use music and rhyme and rhythm. Minimise what needs to be learned by heart. So we're probably going to struggle with times tables. To be fair, if they can learn their 1, 2, 3, 5 and 10 times table, they can do the majority of their tables. Be explicit with language. Like I said before, that word bigger, which number is bigger? What do I mean? Do I actually mean physically bigger, or do I mean which number has the greater value? And very often the word value, we associate it with money. And when we associate something with money, we don't necessarily always associate it with a number on its own. So whenever I've said value to my students before, they've sometimes put the pence sign on the end of it. That's your 10-minute SEN snippet. Thanks guys, take care.